Hey guys, welcome. Yeah, so example 5 here. So something new into our toolbox, and that is that this time we have a denominator that's a repeated linear factor, and that linear factor is x plus 2 and is repeated 3 times. And that's how we have x plus 2 all cubed, right? Now, what you need to know in this situation is because this is 3, and we have a repeated linear factor, that you need to write 3 rational expressions where one denominator is just a linear factor, so x plus 2 here. Another is the linear factor raised to the second power. Since this is 3, you end with the linear factor to the third power. Had this been a 4 here, you would have had to write plus d divided by x plus 2 all to the fourth power. But that's not a 4, so we don't have to do that. Alright, now, next is observe that, as usual, when we have a linear denominator, our numerator is a constant, right? But this here is a quadratic technically, x plus 2 all squared. It's x squared plus 4x plus 4. But because it comes from a repeated linear factor case, we take exception. And instead of having a numerator that assumes linear form for a quadratic denominator, and the event that the quadratic denominator comes from a repeated linear factor, that the numerator then will just be a constant. And so then I don't need to say much for similar reasons. We have a constant here, although the denominator is technically a cubic, which would have meant that our numerator would have to assume a quadratic form. All right, beyond this, business as usual. So we got to get common denominator, so that means we multiply here by x plus 2 all squared, and so we do that here. And then here by x plus 2, and so we do that here. And clearly here we don't have to multiply by anything. And now our denominators are the same, so we can write one denominator, and that denominator is x plus 2. X plus 2 all cubed. That's that, and that's clearly that, and that's the same as that. Maybe like I needed more of this for the numerator, but yeah, here we have ax plus 2 squared plus b times x plus 2, and then plus c, right? And we need this to equal negative 2x squared minus 5x minus 1 divided by x plus, oh sorry guys, divided by x plus 2 cubed. But now clearly this is the same as that, so we only require that this here be equal to that. So can I backtrack and just get the required statement, which is requiring that this be equal to, let's see, can I get this right? Yeah, there. This is the equation we want, right? Like, let's actually slide this down a little bit. Okay, now from the earlier examples, we can take 2 approaches here. One of them is to pick specific x values that will simplify this equation, and so pick x values 3 times to get 3 equations in the 3 unknowns a, b, and c. And yeah, like for example, like pick x equals negative 2, which will make this 0, that 0, and you'll have some computation to do. But I don't want to do computation, so I want to do algebra. So instead what I'm going to do is like simplify this and just compare coefficients with the left hand side. So if we simplify the right hand side, we know we have a times x plus 2 all squared. I already said earlier it's x squared plus 4x plus 4. And then so if we distribute the a to that part, we can keep track. Ax squared plus 4ax, and then plus 4a, that way we don't take too long. And then we have plus bx, distributing the b, plus 2b, and then plus c, right? So collecting like terms, we just have one x squared term, so there's that. But we have plus 4a and then plus b times x. That takes care of this guy and that guy. And then we just have three terms that make a constant. That's 4a plus 2b plus c. Now, we're comparing that to negative 2x squared minus 5x minus 1. So we have that 4a, and I guess I'll do it in a different color. So we have 4a plus 2b plus c has to equal negative 1. And that's because this here, the constant term, has to equal the constant term there. And then we have negative 5 has to, sorry guys, let me draw that better. So negative 5 has to equal 4a plus b. And then the simplest of them is negative 2 has to equal a. How nice. So negative 2 has to equal a. And based on knowing that a has to equal negative 2, this says negative 5 equals negative 8 plus b. So negative 5 plus 8 is going to equal b. And so that's 3 for b. How nice. We know a, we know b, so we can get to c using this first equation. Let's do it up here. So 4a is going to say negative 8, right? And then we have 2b. b is 3, so 2b is 6. And then plus c is equal to negative 1. That's going to say negative 2 plus c is equal to negative 1. And adding 2 to both sides of this equation, we see that c has to equal positive 1. Which means that our factual, sorry guys, I'm tired. Our partial fraction decomposition is done. And our final answer, I think I was trying to say final answer and partial. So that's partial. A is negative 2, so negative 2 over x plus 2. And then b is 3, so plus 3 divided by x plus 2 all squared, and then plus c is 1, so 1 divided by x plus 2 cubed. Yeah, so this plus this equals that. Yeah, that's example 5. And in the next example, I'll show you how to work with a repeated quadratic factor. All right, keep watching. Take care.